So in 5.4, we're talking about trying to take the derivatives and antiderivatives of e to the x. Now, in 5.5, we're going to talk about doing things like 2 to the x. Now, you're going to find that all the rules that work for any base, such as 2, 5, etc., will work for e. So you technically could actually skip this section, but these happen so often and they're so easy that it's worth working on its own. So when you want to take the derivative of e to the u, e to anything, it will just be e to whatever it is times the derivative of the inside. Just chain rule. So the derivative in terms of x of e to the x is just e to the x times the derivative of x, which is 1. Now that being said, the antiderivative of e to the x dx, well, if you think about it, if the antiderivative is nothing changing, if the derivative is nothing changing, then the antiderivative had better be nothing changing. The only thing is, anytime you do an antiderivative, at least a antiderivative without bounds, you have a plus c. So that's really it. Now, before we get into just some of the problems here, a couple things. We want to find the tangent line of e to the 2x at this point. Okay, well, anytime you want a tangent line, you need a point and you need a slope. So to find the slope, we're going to find f prime of 0, which is going to be, take the derivative of e to the 2x, which is e to the 2x, that's the e to the u, times the derivative of the inside, which is just a 2. And then we're going to plug in our point. So e to the 0 times 2, and the 0 is 1, so the slope is 2. So if you've forgotten how to write a tangent line, you have your y minus y1 equals our slope times x minus x1. That's our point slope form of a line. So y minus 1 equals our slope, which is 2, times x minus 0. Or y equals 2x plus 1. Now both of these are good, and actually most of the time I'll leave them in point slope form versus slope intercept form. And if it was a multiple choice question, you'd want a quick look at the answers, because sometimes they'll do things where they put it in standard form. So like 2x minus y equals negative 1, and that doesn't look at all like this at first glance. But you just have to look at the multiple choice questions and see which one is which. But if all you're asking is to write an equation of line, I would stick with point slope form. Alright, so the next section just wants us to do a bunch of derivatives. Alright, so we want to do the derivative of this. It'll be e to the negative x squared times the derivative of the inside and negative 2x. And that's it. Over here, you got a couple of things. You could do the quotient rule, but 2 is a constant, so it's just 1. So I'd do the Hart method. It's actually a hyperbolic. I'm trying to remember if it's sine or cosine. It's not part of the AP exam, but watch what happens with this. It's kind of cool. So the derivative of e to the x over 2 would just be e to the x over 2. Minus the derivative of e to the x, is it to the negative x? Yes. So that would be e to the negative x times the derivative of the inside, which is negative 1, except plus 1 over 2. So I think this was the cosine. I'd have to look it up, and this one might be the sine. But if you look at them, the derivative of 1 is the other. If I take the derivative of this, that negative will show up. So it's one of those that kind of is cyclical. And that's really it. All right, last one. This is using that second fundamental theorem of calculus. So when you're doing the derivative of the antiderivative, you plug in your bounds. So it's going to be ln of e to the 2x plus 1. The plus 1's on the bottom. And then minus ln of, times, here's the big part that people forget. You plug in them, and then you have to multiply by the derivative of whatever you plugged in, which would be e to the 2x times the derivative of the inside, which is 2. And then technically you have minus ln of 1, but times the derivative of the 0 would be 0. So don't forget, you're going to multiply by the derivative of 0, which is 0. So this is our answer. So derivatives are pretty straightforward, and I think you may have done them in math analysis, but the antiderivatives are generally a little bit trickier. So as far in our class, we don't have that many ways we can take an antiderivative. We kind of have to use u substitution or something a little bit more direct, like in the case of number 10, where we're going to do something a little bit easier. So we really try to do like u substitution if we can. And so we pick generally whatever's on the inside. So e to the weird power. I want it to be just e to the u. So we're going to let u be negative x to the fourth. Then du equals negative 4x cubed dx. Well, heck, there it is right there. That's just du. So it's integral of e to the u and then du. Antiderivative du is the basic formula. It's just e to the u. So e to whatever u is, negative x to the fourth, plus c. And that's our final answer. If you take the derivative of this, you'll see that it should actually be that. All right, looking at number 9, first glance you might want to FOIL at the bottom, but I really would not. You're going to let u equal that e to the x plus e to the negative x piece. And we actually did a derivative of that. It was a little bit more complicated earlier. Then du equals e to the x minus e to the negative x, because the derivative of e to the negative x is negative 1 dx. Now the problem is the numerator is not quite that, but it's pretty close. I've got this e to the x, and I got a minus this e to the negative x, I've got the dx. I got this 2 there. So what you can do is you can factor out the 2 off the numerator, and then it becomes e to the x minus e to the negative x dx on top over u squared. Okay, well, this right here is du. Since I took it out the 2, all of this is just du. All right. So we've seen the natural logs. This is not that. It's not the derivative of the bottom being on the top. This is 2 integral of u to the negative 2 du, which then you can use your power rule. So it's 2, you add 1 to it, so negative 1 times the derivative of the power, or divided by negative 1, so negative, plus c, and then you got to plug in your u. So what this works out to be is negative 2 over my u, which would be e to the x plus e to the negative x plus c. And then we're good. So the next one's kind of silly. Natural log of e cancels out, and you've got the integral of 2x minus 1 dx, which is just power rule, so x squared minus x plus c. And that's our final answer.